This is part 4 of a 5-part series, basically an introduction to science and faith. And if you've missed the last several classes we've had, they're all posted on the internet at paradoxes.org and also on YouTube. So feel free to check that out. Today's talk is going to be on the origin of life. And as you can see from the slide here, you can contact us through a variety of social media. Reasons to Believe now has a YouTube channel that runs 24/7, so you can take advantage of that. And you can text my name to 31996. That's your portal to get lots of free videos, book chapters, articles, and much more. And I am still answering all the questions I get on Facebook and Twitter. So if you don't get to ask your question today, you can post it in either one of those two venues. And we are offering a free chapter of our book, Origins of Life. You can get that by going to reasons.org/Ross. And that is a book that's based on the many Origin of Life research conferences that Fuzz Rana and I attended, and some of our own studies as well. And also a sequel to this book, we're making available a free chapter from Improbable Planet. If you want the latest update in the Origin of Life, you can find it there. And again, reasons.org/Ross. Now, to put this in a biblical perspective, Genesis 1 teaches 3 distinct, separate origins of life. And the one I'm going to talk about this morning is the origin of the first life, the origin of physical life. Which is brought up in Genesis 1:2 and 1:3. And then what you see on Creation Day 5 is the origin of a second kind of life, a completely different kind of life that's not just physical, but physical and soulish, a reference to birds and mammals that have been endowed with mind, will, and emotions, and a capacity to form relationships with a higher species, namely as human beings. And what I'm going to talk about next week is the origin of the one and only species that's body, soul, and spirit. So from a biblical perspective, it speaks about life as purely physical, what I'm going to talk about today, but it also addresses life as not only physical, but physical and soulish and spiritual. Now, people have often asked me, can you separate the soul of a human being from the spirit of a human being? I take the position that they're inseparable. So, but this is the whole point. There's a non-physical component to us human beings. But this morning, I'm going to speak about the origin of life that's purely physical. And the real question is life a supernatural event, or did life evolve from a primordial soup? And the idea of a primordial soup actually goes back to Immanuel Kant, but the one that really popularized it was Charles Darwin. And Charles Darwin in his book spoke about life arising in a small warm pond. So that was his idea, that it was a small warm pond. And then when I was at the University of Toronto as a graduate student, I had a chance to take a short summer course from Carl Sagan. And Carl kind of took it from a small warm pond to a really big warm pond. He realized that a small warm pond was inadequate, and so his model was that life arose from a vast sea of concentrated prebiotics that percolated for nearly 1 billion years. And so this led to the non-theistic model for the origin of life. And that model would claim that life arose late, after a period of enormous time, at least 1 billion years, and then that it arrived under benign conditions, that there were very favorable chemical conditions that would enable these chemicals to come together, that it took place in a huge concentrated soup, basically taking all the oceans of the world and filling them with concentrated prebiotic chemicals, and that in that big soup, there were abundant homochirals. And what they mean by that is that the life building block molecules were all oriented in a way that they could assemble. So the amino acids were 100% left-handed, and the ribose sugars were 100% right-handed. And if you know anything about that, they typically come both left-handed and right-handed in a random mixture, and that the origin of life was a single, very simple species of life, much simpler than anything exists on the face of the earth today. Now, this can be contrasted with the story you see in the Bible. And you say, where do you get the origin of life in the Bible? Well, I think you get at least a suggestion of it in Genesis 1:2, where it says, now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. And the word there for hovering in the Hebrew is the word rahab. It shows up only 2 times in the Bible. The second time you see it is in the book of Deuteronomy, where Moses is talking about this eagle that's hovering over her eggs that have just hatched. And therefore, a lot of Bible scholars take the position that the rahab in Genesis 1:2 is referring to the Spirit of God hovering over the surface of the waters and bringing life into existence in those waters, just like a female eagle would be brooding over her eggs that are just about to hatch. Now, it also tells us that this happened when the world was formless and void. And that always has a negative connotation in the Bible. And so this leads to the following biblical predictions on what the origin of life should look like, namely that it would be very early. After all, it's the first thing mentioned in the account of creation, that it would be under hostile conditions, not benign conditions, the formless and void, and that we're going to see not just one species of life, but it's God aggressively creating these microbial species at the earliest moment possible. So we expect to see a complex, diverse, and abundant life showing up right away, that it would be an instantaneous event and a miraculous event. It's the Spirit of God that brings this about, and it's going to be marine species only, because it's at a time when water covers the whole surface of the earth. And so I want to spend the remainder of my time before we get to the Q&A on what science reveals. And science has now given us a definitive answer that the origin of life happens not within a window of 1 billion years, but within a time window that's so narrow we're not able to measure how narrow it is, but we can put limits on it. And where we get this perspective that it happened in a near instantaneous period of time is because of what we know about the bombardment history of the early Earth, that there's something called the late heavy bombardment. And this was discovered by first looking at the moon, Mercury, and then later Mars. When you look at the moon, for example, over 90% of the craters were formed at a time about 3.87 billion years ago. And we can tell that by the erosion that we see on the moon. The moon does actually have a small amount of erosion because it's got a thin argon atmosphere, and it does have a rotation period. So there is some erosion going on there. You get a little more erosion on Mercury because it's got a heavier argon atmosphere than the moon has, and likewise you get the same picture as you do on Mars. You say, what about Earth? Well, the problem with Earth is that it's got such aggressive geological processes going on that the evidence of the late heavy bombardment has been completely erased, although we do see some evidence of it in the isotopes. But the bottom line is that Earth took 30 times the damage that the moon took. So by looking at the cratering of the moon and the seas that were formed there, we can get an idea of the damage that Earth took. And it was such that you're getting 200 kilograms of asteroidal material hitting every square meter of the Earth. So this is a really heavy bombardment. So heavy, it basically turns the surface of the Earth into hot lava. And as such, it'd be impossible for any life to exist under those conditions. And it takes about 40 million years for the Earth to cool enough where we get rocks. And so we're able to date when we get the first rocks after the late heavy bombardment, and that date is 3.825 billion years ago, plus or minus 0.006 billion. So that's kind of the error bar. But what we notice is those various oldest rocks, the oldest rocks we see in the face of the earth, have the isotope evidence of life. And so it tells us life was here the moment that the late heavy bombardment allowed the earth, it had subsided enough that we actually get rocks forming out of the liquid lava. And here's a quote from Niles Eldredge, probably America's most famous non-theistic evolutionary biologist. And this is in his book with the rather triumphal title, The Triumph of Evolution and the Failure of Creationism. It's basically a critique of young earth creationism. But one of the things he says in this book is, one of the most arresting facts that I've ever learned is that in the very oldest rocks that stand a chance of showing the signs of life, we find those signs. In other words, the very first moment that life can possibly exist on the earth, life exists. What does that tell us? Life originated in a window of time that's extremely narrow, less than 6 million years wide. We have the origin of life. That's as accurately as we can measure it, basically telling us the origin of life didn't happen over 1 billion years. It happened in an immeasurably brief period of time. Now, not only did the origin of life happen in a very brief window of time, we also have evidence it happened without the benefit of a primordial soup. And I think you can see where I'm going with this. If you don't have time and you don't have soup, you don't have a naturalistic model for the origin of life. I mean, you don't have to be a biochemist to figure that out. No time, no soup, no naturalistic model. Now, the reason why we can conclude there was no primordial soup on the face of the earth is that the molecules that you take to assemble to make the proteins, RNA and DNA, and they're made up of amino acids and sugars, and life likes the isotopes of carbon-12 compared to carbon-13, and it prefers nitrogen-14 to nitrogen-15, and it prefers sulfur-32 to sulfur-34. Now, these are all non-radiometric isotopes, and they exist on the face of the earth. And that's how we can distinguish between a postbiotic molecule and a prebiotic molecule. A prebiotic molecule will have a higher ratio of carbon-13 to carbon-12 than a biological molecule or postbiotic molecule, because life prefers the lighter isotopes. And in every single case, when we look at the amino acids that date back to that time, we see that it has a higher ratio of carbon-12 to carbon-13, nitrogen-14 to nitrogen-15, and sulfur-32 to sulfur-34 than we'd see in the prebiotics. Matter of fact, it's such when we look at these most ancient isotope signatures, we see zero evidence of prebiotics. Everything we see is postbiotic. None of it is prebiotic. What does that tell us? There were no prebiotics on the face of the earth when the origin of life took place. Now, the last Origin of Life conference that Fuzz and I attended was at the University of California, San Diego. By the way, these conferences are held every 3 years, and we make it a point to go to every one that's held in North America. And the last one was July before last, University of California, San Diego. And the highlight of the conference, Wednesday night, they had 5 of the world's leading Origin of Life researchers in different disciplines answer the question, can the formation of the building blocks of life be considered as solved? And so all 5 had 15 minutes to speak. All 5 concluded with an emphatic no. In fact, when it got to the Q&A time, they got up and said, not only have we not been able to figure out where the building blocks of life come from, we don't even know where the building blocks of life come from. In other words, we can't even figure out where the simple stuff, the amino acids, the nucleobases, and the sugars come from. And from an astronomical perspective, we got the problem that nowhere in our Milky Way galaxy or outside of our galaxy have we been able to detect any of the amino acids, ribose sugars, or nucleobases. The amino acids, if you're not a biochemist, those are the building blocks of the proteins, and the nucleobases and the ribose sugars are the building blocks of RNA and DNA. Now, there was a claim made in the Astrophysical Journal about a decade ago that they had found the simplest of the amino acids in a dense molecular cloud, namely a glycine. It only has 10 atoms. But a couple of years ago, a paper was published where they said, we misidentified the spectral lines. It wasn't glycine after all. We've not found it. And likewise, a claim that they had found one of the simpler nucleobases also has been withdrawn, and everyone recognizes they've not been able to find ribose anywhere. If you don't have ribose, you can't join the nucleobases together. Now, I'm on record as saying I think we eventually will find in these dense molecular clouds. You say, why are you referring to dense molecular clouds? It's the best place in the entire universe for these things to assemble under natural conditions. In these clouds, we have over 135 carbonaceous molecules. We've been able to detect them. And we also know that the chemistry is there to make possible the manufacture of amino acids, the nucleobases, and the ribose. But we also know that there's chemistry there that destroys them almost as fast as they're being constructed. And so I've been on record as saying eventually we will find them when we get the detection capability of finding them at abundance levels of like a part per billion. But if we're talking a few parts per billion or less, then all origin of life researchers recognize that's a concentration level far too low to be of any benefit for any possible origin of life model. Now, as we've been attending these origin of life research conferences, the last two conferences have been really focused on what they've been able to do in the lab. And so they're basically constructing these nucleobases in the lab and amino acids, and they're finding ways to join them together. Basically, they developed these very sophisticated clay mineral substrates, and they've been quite successful at forcing these things to join together. But one of the things they discovered as they try to join together these building blocks is the more of them they join together, the harder it is to make the next one join together. Moreover, once you get up to about 40 of them in a chain, you can't get them off the substrate. And there's an adhesion problem, and the substrate won't let them go. And it's like if you can't get them off the substrate, you're not going to be able to use them to make anything more complex, and it literally breaks down at a level or 40 or 50 amino acids joined together. And as you're probably well aware, many of the proteins that are essential for you to be here today require 10,000 plus amino acids to be joined together. And so even the simplest protein we see in the human body has over 100 amino acids linked together, and we're not able to get past that. But that explains why my colleague Fazal Rana, our staff biochemist, wrote his book, Creating Life in the Lab, and was basically making the point. Notice it takes a biochemist with a lot of education, knowledge, sophisticated lab equipment, and government funding to make even these tiny steps towards the assembly of these life systems. And his whole point is somebody a whole lot more intelligent, more knowledgeable, with more better technology and a lot more funding must have been responsible for the origin of life in the beginning. And just a few weeks ago, this was actually recognized in the prestigious British journal Nature, where they said one of the things we biochemists have been guilty of is the hand of God fallacy. That was their terminology, the hand of God fallacy, basically saying what we do in the lab is really no different than a supernatural intelligent being using the same procedures. Okay, moving on. We now know there was no time, and there was no soup. And back in 1999, that was the first Origin of Life research conference we attended, a Romanian physicist spoke. And he spoke about what's called the oxygen ultraviolet paradox. And here's the problem. In all these experiments in the laboratory where they're putting together these molecules, or you may have heard of the Stanley Miller experiment. Any of you ever heard of the Miller-Urey experiment? I think it's in all the high school textbooks. And this was back in the 1950s where Stanley Miller had this little flask, and he put some chemicals inside, and he was able to get glycine, the simplest of the amino acids, and said this is how the origin of life happened. But what the Romanian physicist pointed out is all these experiments, even the ones that are much more sophisticated that are being done today, they scrupulously make sure there's no oxygen in the flask. The tiniest amount of oxygen kills the reaction. You get nothing. And so, but here's the problem. If you don't have oxygen in the Earth's environment at the time of the origin of life, then you got nothing to prevent ultraviolet radiation streaming into the surface of the Earth. It's ozone, the byproduct of free oxygen, that protects us from the hard ultraviolet radiation from the sun. And it's that UVB radiation that shuts down prebiotic chemistry. So he basically said, here's the paradox. If you got oxygen, it can't happen. If you don't have oxygen, it can't happen. And he said, but mainly his talk was, he says, I think the answer is we do have oxygen. He was simply making the point that planet Earth is super endowed with uranium and thorium. It's the uranium-thorium champion of the universe, and it's everywhere. And as that uranium and thorium decays, the energy released from that radiometric decay causes water in the oceans to split into oxygen and hydrogen. And so he says that's going to provide enough oxygen in the oceans and in the atmosphere. You don't need much, but that tiny amount is enough to shut down the chemistry. And what was the heart of the Origin of Life research conference a year and a half ago was the homochirality problem. And so several researchers got up there and said, this is what we've been able to do in the lab. They basically have found that there are a couple of pathways, sophisticated pathways, where they can actually take a mix of amino acids, and by using circularly polarized ultraviolet light or by using the neutrino decay process, they can destroy the right-handed amino acids more efficiently than the left-handed amino acids. And so they said, this is how we think homochirality actually came about. And by the way, they have found one natural source for this kind of radiation. Right next to black holes and neutron stars, you do get circularly polarized ultraviolet light. But I can't think of a worse place in the universe to try to make biochemistry happen than adjacent to a black hole or a neutron star. But that is the one place where you get the required circularly polarized ultraviolet light. But this is done in the lab, where we can do this in the lab. And what they discovered is you can take a big mix of these amino acids, and yes, by exposing them to 100% circularly polarized light, you do get more and more of the amino acids becoming left-handed as opposed to right-handed. But what they announced at the conference is by the time you get to 80% left-handed compared to 20% right-handed, you don't have any sample left. And they said, all of our experiments tell us, but if you were ever to get close to 100%, you got no amino acids left. Because basically it's a destruction process. You're destroying one hand more efficient than the other hand, but the bottom line is, before you get to 100%, everything gets destroyed. So, and incidentally, this only happens under controlled laboratory conditions. So the conference concluded, said, we still have a really big problem because you can't join together the amino acids unless they're all left-handed. It's kind of like putting together Lego blocks. If they're not oriented the right way, they're not going to go together. And you got the same problem with the ribose sugars. Unless the ribose sugars are all right-handed, you're not going to be able to join together the nucleobases. And then finally, a problem they've discovered is that these amino isotope signatures tell us that the origin of life is not one simple bacterium. It's a whole ecology of microbes. So how did they figure that out? Well, different species of bacteria will manifest a different isotope ratio than other ones. And what they see is they get a whole family of these isotope ratios, including the isotope ratios you would expect for photosynthetic bacteria. Now, these are really complicated bacteria. We're not just talking 400 or 500 gene products. They have 1,500 plus up to 4,000. And so even the most complex microbes we see in the face of the earth were present there at the origin of life. Now, incidentally, this is what we'd anticipate from a biblical perspective, that God would put an abundance of these microbes on the face of the earth with great diversity. Why? Because he has a goal of bringing humanity on the face of the earth before the sun becomes too bright to allow human beings to exist. You may not be aware of this, but in about 10 million years, we're all toast. The sun will literally be too bright to permit the existence of human beings. But God knew this in advance and says, we better get going on these microbes because we want to get human beings on the face of the earth before the sun becomes too bright to prevent their existence. And you actually see that in Psalm 104, how God packs the earth with as much life as possible, as diverse as possible, for as long as possible, in order to provide us human beings with all the biodeposit resources we need to sustain a large population and high technology civilization. Look around you. All the building materials we see in this vast metropolis of ours comes from billions of years of life that preceded us. The concrete, the metals were concentrated by these bacteria, the marble, the coal, oil, natural gas. And this explains why at these Origin of Life conferences, what we notice is they quickly give up on planet Earth. And so the model that was first proposed is life did not originate on Earth because of what I just described. Life must have first originated on Mars, and then some meteor struck Mars and caused that first life form to be deposited on the face of the Earth. However, even back in 1999, they were quick to rule out Mars as a candidate. Why? Because you got the same problem. It would have to happen in an instant of time, and unlike planet Earth, you got a carbonate crisis on Mars. Mars doesn't have the plate tectonics to recycle the carbonates. And so what happens is if you ever have a warm, wet environment on Mars, and we actually have evidence that there was a time about 4 billion years ago when Mars was warm and wet, but it was extremely brief. Why? Because if you got warm, wet conditions, the water will react with the carbon dioxide and make carbonates, and the carbonates permanently pull water and carbon dioxide out of the environment. And when that happens, Mars quickly becomes very cold and very dry, and it's a permanent condition. And that's confirmed by the fact that when we look at the craters on Mars, we see that they have very little evidence of erosion, which means that the water must have been there for a very brief period of time, which is what we'd expect from the carbonate crisis. And Mars, just like planet Earth, has got the same oxygen ultraviolet paradox, and you got the same problem with no solution to the homochirality. And I remember back in 1999 and 2002, the conference basically eliminated planet Earth, it eliminated Mars, it eliminated all the moons of Jupiter and Saturn, basically eliminated the solar system. And so they said, well, then it must have come from outside the solar system. And the first proposal was, well, it was interstellar dust, that somehow there was a bacterium that was embedded in some little dust particle, and the dust particle got wafted over to the Earth. And we noted, for example, as I've already said, these dense molecular clouds seem to be the best place in the universe where you got an abundant supply of carbonaceous molecules, and therefore it must have happened there, and then somehow a bit of dust got wafted into the Earth. But one of the things we've noticed about these interstellar molecular clouds, there's no ammonia. Now, I think eventually we will detect ammonia there, but it's clearly at a very low abundance level. And ammonia is crucial for any of these origin of life assemblies. And as I've already mentioned, there's no ribose, the 5-carbon sugar, none of the 6-carbon sugars either. They have found 3 carbon glycoaldehydes, but none of the sugars that are essential for life, and no nucleobases, and no amino acids, and no source of homochirality. And moreover, we got the problem that if you do have a bit of dust with some life in it, or these amino acids or proteins in it, you got the problem of what happens as they get transported to the Earth. And so you got some comet or bit of dust coming into the Earth, but as it goes across interstellar space, it gets exposed to X-ray and ultraviolet radiation. And that X-ray and ultraviolet radiation will basically break down anything that was in the proteins or the RNA or the DNA that's embedded in that dust. And moreover, we're looking at millions of years for it to traverse interstellar space, and you've got very short half-lives. Some of the half-lives are just minutes. And so clearly you're not going to get this thing going across interstellar space in just a matter of minutes. That violates the velocity of light. And then it's got to get through the atmosphere. And when it gets through the atmosphere, it gets heated up, and that also breaks down the chemistry. And back in 2002, this was acknowledged that the panspermia model that Fred Hoyle had popularized simply was not going to work. And that if you're going to get anything from another planetary system, it's going to have to be inside not just a bit of dust, but a really gigantic rock. In fact, I heard one scientist get up and say it would have to be in the middle of a rock at least 2 meters in diameter, where the rock has no porosity and no cracks. And we need it right in the middle in order to give it adequate protection from the radiation it's going to experience as it goes through interstellar space. But then there was an Australian physicist that got up and did a calculation how frequently we'd expect to get a rock the size of a human fist, not 2 meters across, just the size of a human fist, transported from one planetary system to our planetary system. And he calculated we're going to get the delivery of one of those rocks every 10 to the 16 years. Now, that's 1 million times older than the age of the universe. And so he basically said, we're not getting any rocks, even the size of a human fist. And that's when a scientist came up to the Q&A microphone, because after every talk they allowed people to engage everyone. That's what's fun about these conferences. And he says, what we've done at this conference is we eliminated planet Earth as a candidate, we eliminated Mars, we eliminated all the bodies in the solar system, we eliminated panspermia, we eliminated a rock of any kind coming to planet Earth. There's only one possibility left. And he basically raised the model that was proposed by Leslie Orgel back in the 1980s. Francis Crick and Leslie Orgel wrote a book where they basically said the only way to explain the origin of life on planet Earth is directed panspermia. And this is the idea that intelligent aliens in spaceships visited the Earth 3.825 billion years ago and deposited life here on planet Earth. And as a scientist said, they probably came back several times, because after all, we got these mass speciation events in the fossil record. So that would explain where the dinosaurs come from, that would explain where the first mammals come from, and the birds. These aliens just kept coming back, and we're kind of their zoo. But it raises the issue. How do you explain the origin of the aliens? And this has really been killed at the last Origin of Life conference, because several astronomers made the point. If we're talking about intelligent life, the earliest you can get it to appear in the universe is 13.8 billion years after the cosmic creation event. Well, guess what? That's how old the universe is, 13.8 billion years. And these astronomers have basically been making the point, if there is extraterrestrial intelligent life, it's got to be here after us. We're the very first. There's no way you can get intelligent aliens any earlier than 13.8 billion years. If you want to read why, I describe that in some detail in my book, Why the Universe is the Way It Is. But it makes the point. It couldn't have been intelligent aliens from another planetary system 3.8 billion years ago, because it would have been impossible, physically impossible, for those beings to exist. And also you got the problem, how are they going to get here across interstellar space? And this is an issue I brought up in our book, Lights in the Sky and Little Green Men, basically making the point, hey, if you read this book, it's going to really kill your enjoyment for Star Trek and Star Wars. Because I simply make the point, you cannot take physical intelligent beings and move them across interstellar space. If you put them in a spaceship, there's a limit to how fast you can make the spaceship go. If you make it go faster than 1% the velocity of light, you're going to run into enough interstellar material, it's going to destroy the craft and kill the individuals on board. So you got to go slower than 1%. And if you go slower than 1%, you're looking at travel times in excess of 25,000 years. And the problem with that is there's good scientific evidence that it's not possible to sustain high technology civilization for more than 2,000 years. You say, what does that mean for us? Well, we've only had it for 200 years. We got 1,800 years to go. But yeah, there's going to be a limit to how long we can sustain it, even here on Earth. And so that tells us that it wasn't intelligent aliens from the planetary system. So what's left? Well, what's interesting is that the Santa Fe Institute, headed up by Stuart Kaufman, recognized this more than 2 decades ago. Basically, when they looked at the book by Leslie Orgel and Francis Crick, they basically said, Crick, that the only possibility is maybe there's a hidden law of physics, and maybe that hidden law of physics counters the second law of thermodynamics. So instead of things naturally decaying with respect to time, they naturally progress with respect to time. And so clearly that doesn't happen anywhere in our galaxy, but maybe somewhere outside of our galaxy, there's an exotic spot in the universe where you've got a fourth law of thermodynamics where it works the opposite way, and that explains the origin of life. Of course, now you got the problem. How do you get it from outside of our galaxy, inside of our galaxy? Because once you get inside of our galaxy, you got the second law of thermodynamics operating. Well, actually, there's a very good refutation of this. Life is simply not possible unless the universe has a high degree of homogeneity and uniformity. What does that mean? There can't be an exotic spot anywhere else in the universe where you got a fourth law of thermodynamics operating. And for what it's worth, this claim was made by Stuart Kaufman 30 years ago. We astronomers now have the telescope power to tell you that the second law of thermodynamics is ubiquitous. Every star and galaxy we observe, every gas cloud we observe throughout the entire universe does obey that second law of thermodynamics. So what's really left? The Spirit of God was hovering over the surface of the waters and supernaturally created life here on Earth. And you can read about it in our book, Origins of Life. And incidentally, when we published this book, we got a phone call from a fellow we had met at the Origin of Life Research Conference, David Deemer. And he's been at every one of the conferences we've been at, one of the world's foremost Origin of Life researchers. And when he called us, he said, I've read your book. I'd like to do a review of it, and I'd like to publish it in Origins Life and Evolution of the Biosphere, a peer-reviewed journal. And he says, I am an atheist. I'm going to be very critical as I review the book. Do I have your permission? And we basically said, yes. Be as critical as you can possibly be. We're intended to keep revising this as science progresses. We can only benefit from your critique. We respect your work. We've been reading your papers. And so he wound up publishing it. And you can go to that journal and find the review. And bottom line is what he says, this is the best interdisciplinary treatment of the origin of life. He's very commendable on the science we've written. And the bottom line was, I like everything in the book except the Jesus Christ part. So, and then you can get an update in Improbable Planet. Well, I'd like to segue to Q&A, and you can ask me any question. It doesn't have to be in the origin of life, but we do have a few suggestions about your questions. If you're here, raise your hand. Wait for the microphone to come to you. We're going to have a roving microphone. And when you do get the microphone, stand up and speak directly into the microphone. We had some issues with people holding the microphone like this. You need to be right up close to it, speak right into it, and please be concise. We'll also be taking questions from the live streaming audience. As many of you as here today, we got a lot more that are participating through live streaming. So we're going to be taking their questions as well. But we already got a hand up here. Can we get a microphone over here? Okay, we're getting set up on the microphone. And in the meantime, do you have a question from the live streaming audience yet?
Yes, we've actually got a dozen questions.
Got a dozen questions from the live streaming audience. Okay, we'll alternate back and forth.
I can speak up.
Okay, speak up. I'll try to repeat it for you. Okay.
And I can't stand up, but okay. One thing confused me here. You're saying that we can't have life in the universe until 13.8.
We can't have the equivalent of human life in the universe. Okay. Bacterial life is possible 3.8 billion years ago, and that's something I didn't comment on, but that's also a point. The earliest you can have the simplest life is 3.8 billion years ago. And guess what? We get it 3.8 billion years ago. The earliest you can get intelligent physical life is 13.8 billion years after the cosmic creation event. So thank you for that clarification. Okay. Okay, we got a question from the, right here.
In chapter 1 of Genesis, verse 3, it says that God said, "Let there be light."
Yes.
And there was light. And then further down in verse 4, he separated the light from the darkness. I mean, light is just consistent. So what's going on right there?
Okay. Creation day 1, Genesis 1:3, let there be light. This is clarified in the book of Job, chapter 38, verses 8 and 9, where it says God had blanketed the seas with clouds that kept the seas dark. And so you see that in Genesis 1:2. Darkness was over the whole face of the deep. And so evidently earth had clouds that were opaque to light. So what happened in creation day 1, God transformed our atmosphere so the light that was blocked from the sun, moon, and stars could now come through the atmosphere and reach the surface of the earth. Now that would be important if you want photosynthetic bacteria. That's something already said. At the very origin of life on planet Earth, we see the isotope signatures that tell us that at least some of those bacteria were photosynthetic. That can only happen if there's light streaming in from the sun. But when it talks about God separating light from darkness, it's simply making the point from the perspective of the surface of the earth, you can now see the effect of the rotation of the earth. You're getting a cycle of daylight and darkness, whereas before all you had was pervasive darkness. But with the clouds now becoming clear, the rotation of the earth with respect to the sun gave us this 24-hour cycle of approximately 12 hours of light, followed by 12 hours of darkness. Okay, we got another question, or do you have one from the...
This is from the online audience. Tony asks, regarding the theories of the multiverse, can Dr. Ross speak to how the theistic model is scientifically sound, whereas the atheistic interpretation is flawed? And going along with that, Can we be scientifically certain there is no physical universe before the Big Bang?
Okay. If you want a detailed answer to that question, it's covered in the 4th edition of The Creator and the Cosmos. So I'll try to be brief. For those of you who are not familiar with the term, multiverse is an hypothesis that instead of the universe having just the universe we see, there's actually an infinite number of universes. And the non-theists have proposed that this hypothetical ensemble of an infinite number of universes are all different from one another. And if they're all different from one another, they're arguing that all of these fine-tuned features we see in our universe that make possible our existence are the product of pure chance. They're not the product of supernatural design. If you've got an infinite number of possibilities, where all the possibilities are different from one another, then you can get us by chance. I mean, to give you an analogy, it'd be like saying, okay, if I flip a quarter 10 times, I'm likely to get a random mixture of heads and tails. But it's actually possible if there's an infinite number of quarters being flipped by an infinite number of people, one of those will come up heads 1 million times in a row. That's a possibility. So it's kind of using the same analogy. Now, a response I put in The Creator and the Cosmos 4th edition is one from Leonard Susskind. He himself is an atheist, and he says, we atheists have got to stop using the multiverse as an attempt to deal with this fine-tuning problem. Because he was basically making the point, the problem with the way it's being presented is it explains everything. And he says a model that explains everything explains nothing. Now, he just stopped with that. But I gave an analogy in The Creator and the Cosmos, basically saying if you've got an infinite number of universes where they're all different, you're going to have an infinite number of planets with trees on them. In fact, you're going to have an infinite number of planets with birch trees on them. And you know the property of birch trees? They peel white pieces of bark. But if you've got an infinite number of universes, you could actually have an infinite variety of species of birch trees. And one of those species of birch trees would peel thin sheets of white bark that are 8.5 by 11 inches and perfectly square. And you could actually have them falling on soil in an infinite number of universes where you got chemicals in that soil that put random markings on those pieces of birch bark. Random markings that are identical to all the symbols, letters, diagrams, and equations you see in every research paper published by every physicist in the world. Which means all of those research papers didn't come from the minds of those physicists, the multiverse did it. So the whole point is, yes, you're proposing the multiverse to explain away divine design and the mind of God, but it actually explains away all design and all minds, and therefore it's inconsistent. Now, what I've added in The Creator and the Cosmos is a positive way to approach the multiverse, basically making the point that if the atheistic version of the multiverse is correct, at some point we're going to see the fine-tuning evidence plateau and decline. We certainly wouldn't expect it to exponentially increase, but it's been exponentially increasing for the last 60 years that we've been making the appropriate measurements. In fact, it's increasing at a rate that's at a minimum of a factor of 1,000 times per month, which means every month that goes by, we get 1,000 times greater evidence that a supernatural mind is behind all this fine-tuning. And I often say that when I'm at an apologetics conference. Where else can you go in Christian apologetics and get 1,000 times more proof in a single month? That's one place where you can get it. I think it also explains why the multiverse was proposed. What are you going to do when you're faced with this overwhelming evidence? Creator and the Cosmos gives you much more detail. And we got a hand here. If we can get the microphone.
I think I can talk about it.
Okay.
Between Genesis 1:1, where God created, and Genesis 2:2, where it's formless and void, why would God create something formless and void?
Okay. Okay, I'll repeat the question. I was just talking about Genesis 1:1 and 1:2. 1:1, in the beginning, God created the universe. 1:2, it speaks about God now beginning to focus on earth. and talks about earth being formless and void. And why would God create something formless and void? Well, when I was a teenager reading the Bible for the first time, I started on page 1, and I'd been taught the scientific method in my public school education, literally from grade 1 onwards. And so being steeped in the scientific method, I looked at Genesis 1 and said, wow, notice it begins by giving you the frame of reference. That's step 1 of the scientific method. Don't interpret till you first establish the frame of reference. The Spirit of God is hovering over the surface of the waters. Step 2 of the scientific method, don't interpret until you establish the starting conditions. So that's how I interpreted Genesis 1:2. It's simply giving us the starting conditions before God begins to supernaturally intervene. And the 4 starting conditions are, it's dark everywhere on the surface of the earth. Water covers the whole surface of the earth. The earth is unfit for life, and it's empty of life. But now God begins to work. And so it's not God creating something that's ruined. It's kind of thinking like a potter. In fact, God often refers to himself as being like the potter. And you take this lump of messy clay, and you make something out of it. And that's kind of what God did with the earth. He created the universe, then he found this little mess of clay, and now he's forming it into a very beautiful system where we can live. And it was 9 years after picking up the Bible for the first time that I finally figured out where the scientific method came from. It actually came from the Bible. There's a good reason why the Bible follows it. That's where it actually comes from. When the scientific revolution basically came out of Reformation Europe. And so it's no accident that that's where it came from, because what people were doing is the first time people were reading the Bible for themselves. Those with the scientific bent looked at the various creation texts in the Bible, and they saw not only the Bible commanding objective testing, but showing us step by step how to put everything to the test. You even see it in the first 3 verses of Genesis. Good question. Thank you. Yes.
Brian Greene said that there was some evidence that from the cosmic background radiation map that we're running into another universe. There's some collision in there. Is that true? Or is there that publication?
Hey, if you haven't heard that, he's referring to the cosmologist Brian Greene. He's on TV all the time. Interesting astrophysicist, because he's also a professional actor, so he actually looks good on TV. So. But he was making the comment that when we look at maps of the cosmic background radiation, those are maps of the radiation left over from the cosmic creation event. We see what looks like a subtle distortion that could be evidence that our universe collided with another universe. And that's something that's still being debated as we look at these cosmic background radiation maps. We see what appears to be a departure from thermodynamic equilibrium, so there is this little distortion in one part of the maps. However, the statistics are such that we can't be certain that it's a real distortion. It might be, it may not be. And Brian Greene, if I remember right, is basically calling for better maps of the cosmic background radiation. But the best map we have has a subtle hint of a possible distortion. Now, one explanation if the distortion is real, then his suggestion that maybe we bumped into another space-time realm is a possibility. But there are many other explanations for what could cause that distortion. I know of at least 6 that have been published in the astrophysical literature. So this is being debated. But we still don't know if the distortion is real. The assumption is, if it's real, what's causing it? And there's multiple ways of explaining that distortion, but bottom line is we really do need a better map of the cosmic background radiation. And the Planck map was good, but it ran out of liquid helium after just 15 months. I've been suggesting we need to do it again, but let's send up a 5-year supply of liquid helium instead of a 15-month supply. Then we can get a really good map and see what's going on. As it is, there are maps being made down at the South Pole where they're trying to measure both of the polarization modes. And that's going to give us a lot, and that'll be published probably within the next 2 years. And that doesn't need any funding. It's already happening. We'll keep you up to date. Once that comes out, we'll let you know. Because it'll also tell us what kind of inflation event happened. And that really will tell us if there's a possibility that there could have been other space-time bubbles that spawned off in the inflation moment, or there's a possibility one of them could have bumped into ours. Incidentally, cosmic inflation is completely compatible with a Christian worldview. Only if you got an inflation incident taking place when the universe is 10 to the minus 35 seconds old is there the possibility for future life. Because a lot of Christians have been trying to claim that this is something that's counter. It's not. It's exactly what you need from a creation perspective to get future life. Yes. Oh, over here.
Got another online questions from Ryan Lee. His question is: Would early fossils on the moon put an end to the origin of life debate?
Well, that's something I called for back in 2009. That we need to go back to the moon. We don't have to send people. It can all be done with machines. The reason why is, in fact, there was an astronomer that was in this class here many years ago, Guillermo Gonzalez, and he and two other co-authors wrote a paper many years ago making the point that there is about 200 kilograms of Earth material on every 100 square kilometers of the surface of the moon. 20,000 kilograms. 200 is the figure for Mars. But there's 20,000 kilograms for every 100 square kilometers of the moon. And 1 ton of Earth's soil contains 100 quadrillion microbes. And they produced a future paper where they said, we think the moon's the place to go because we got evidence that that Earth material arrived on the moon with low velocity collisions, which means that those microbes of Earth's first life will be on the surface of the moon in pristine form. Now we're talking fossils, of course. They're not going to be alive, but they'll be fossils. We don't have the fossils of Earth's first life here on Earth. Earth's geology has destroyed those fossils. All we have is the isotope evidence. But we could actually go to the moon and find the fossils in pristine form of Earth's first life, because most of that delivery of 20,000 kilograms per 100 square kilometers arrived at the time of the origin of life on planet Earth, or very soon thereafter. Now, I got to speak on this subject when I was at NASA Houston, and basically said, we can go back to the moon and figure out who got the origin of life model right, the theists or the non-theists. The non-theists predict it'll be a single species, and it's going to be a very tiny microbe, 1/10 of a micron across, and it's going to be having very simple biochemistry. Theists, on the other hand, are predicting it's going to be a complete ecology of microbes. We're going to have small ones, we're going to have big ones, we're going to have non-photosynthetic, we're going to have photosynthetic. And there's going to be a lot of them. We're not just talking having to search through hundreds of thousands of tons to find a single fossil. We can go to the moon and see who got the origin of life model right, the theists or the non-theists. And I closed my talk at NASA Houston saying, last time I checked, that made up 100% of the U.S. taxpayer base. So everybody should be excited about NASA going there. And I tried to sell it by saying, if you could solve the origin of life, quote, problem, I think the taxpayer base is going to be really excited about continuing financial support for NASA. And it's relatively cheap. It wouldn't cost a lot of money to figure that out. Now, as I understand it, the focus of NASA is Mars, but the Chinese are really interested in the moon. And they know about this, and so they could be the ones that figure out who got it right, the theists or the non-theists. I'm happy whoever figures it out. Okay, who's next?
Could you address, has there been any research on the idea of quantum physics and dark matter that has anything to do with the origin of life?
It wouldn't have anything to do with the origin of life. You will find a couple of chapters on this in The Creator and the Cosmos, 4th edition. It's our latest stuff on what's called the quantum gravity speculations for the origin of the universe. And a number of non-theistic physicists have made the point, well, we got a good understanding of the characteristics of the universe all the way back to 10 to the minus 43 seconds after the origin of the universe. Then we don't have a good knowledge of what happened between time equals 0 and time equals a 10 millionth of a trillionth of a trillionth of a trillionth of a second. That's our window of ignorance. I'm rather impressed that our window of ignorance is that tiny. But they're saying in that window, gravity would be competing with quantum mechanics. And so they refer to it as a quantum gravity era, where the forces from quantum mechanics would be equal to or greater than what you would get from gravity. And they're saying that could conceivably change the dynamics of the universe so radically that maybe there isn't a beginning to the universe. Now, what I wrote about in The Crater and the Cosmos is that there actually is the possibility that we can penetrate the quantum gravity era. For example, right now there's an array of radio telescopes around the world that are going to be producing a map of the event horizon of the supermassive black hole, the center of our galaxy. Now, what happens outside of the event horizon gives us information of what can happen in the quantum gravity era and what cannot happen. And already we have images of distant quasars and blazars where we can measure the sharpness of the image, because what the atheists are speculating is that the quantum space-time fluctuations in the quantum gravity era are so large that maybe they allow a possible escape from a cosmic beginning. But if they're large as they say, it will blur the images of distant quasars and blazars. And as you look at those images, they're crystal clear sharp. So it tells us the fluctuations can't be as big as what they say. And then there's actually a theorem produced by Aaron Wall. He's a Christian theoretical physicist, where he basically says, no matter, we already have enough information what goes on in the quantum gravity era to tell us that space-time theorems hold all the way back to t equals 0. Bottom line, there is no escape. The other problem that I addressed in the 4th edition of The Crater and the Cosmos, if you have another universe that somehow is contracting and is joined to our universe that expands, that's what all the models that non-theists are producing claim. It was Roger Penrose who said, you can't join the geometry of a collapsing universe to the geometry of an expanding universe. And so there really is a beginning. And guess who said it first? All right.
Okay, here we got another online. This is from Tansui. Is there anything you know about Charles Frank from Bristol University and his 3 super important tests for the origin of life?
How do you spell the Frank? Is it F-R-E-N-K?
Well, he's spelling F-R-A-N-K. But
Yeah. I'm gonna pass on that one. I have commented on it on our reasons.org website. So if you want to do a search of the name, that'll pop up an article I wrote. But I just don't have good enough recall to. I could take a chance on answering the question, but I'd rather not take a chance. But I have written an article on his speculations.
Okay, we've got one more from Ryan Lee. And Tansui was from Brazil, so welcome, Brazil. Ryan Lee, what is the natural evolution response for new species appearing so fast after the mass extinctions?
Okay, how do naturalistic evolutionary biologists explain the rapidity of the mass speciation events? And this is in response to the fact that there are a number of mass extinction events in the history of the Earth. The most dramatic one wiped out 90% of all the species of life, both in the oceans and on the land. And we notice is there's always a rapid recovery from these mass extinction events. And I think one of the biggest challenges to naturalistic models, when you do see the recovery is instantaneously ecologically optimal. What do I mean by that? Well, you've got herbivores, you've got carnivores, you got parasites, and you got detrivores. Detrivores are animals that clean up the decay products of dead organisms. You need all four in a highly fine-tuned relationships with one another in order for everybody to have a high quality of life. So you actually do need parasites, you do need carnivores in order for the herbivores to have a high quality of life and to minimize the suffering of life. And when you look at, say, carnivores and herbivores, the thing you notice is the carnivores are designed in such a way that they can only eat the weak, the injured, the sick, and the dying. And that actually preserves the health and the population base of the herbivores. They get protected from the propagation of disease and other things. And so that's a benefit. But notice the herbivores are not equipped so that they can kill the healthy ones. They have to kind of feed on the fringes. And notice they are equipped to be able to feed in those fringes. So for example, things would be out of balance if the carnivores weren't able to kill any of the herbivores. And it'd be out of balance if the carnivores could kill too many of the herbivores. But we see there's always a perfect balance. And likewise a perfect balance with the parasites and with the detritivores. And so the fact that we see that immediately, because naturalistic models would predict that it would take tens if not hundreds of millions of years for these ecological relationships to optimize, and moreover, that may be so much time that you wind up with greater extinction rather than less extinction. And then the rapidity with which you see the radiation events. The most rapid replacement we can document is the replacement of the Jurassic animals after the Triassic animals. We're actually looking at a window that's only 10,000 years wide or less. Now, the way evolutionists respond to this is say, well, we think we've got 40 million years. But they're referring to places where that's the error bar. The error bar is 40 million years or less. It could be 0, it could be 40 million. But that's something I've noticed in the evolutionary biology literature. They always go to the widest part of the error bar. But as a physicist, it's like, okay, you got to look at the smallest part of the error bar too. 0 to 40 means it could be 20, could be 10, could be 40, it could actually be 0. And where we got the best measurements, the best measurement is 10,000 years. That tells us it's between 0 and 10,000. 10,000 is a very short window of time, too short for any naturalistic model. Okay, who's next?
With all of the assuming of multi universes and stuff like that, is there any work on scientists trying to mathematically prove perhaps the kingdom of God, since that's in another dimension? We know that our universe takes at least 10 dimensions. I mean, is there any chance of that?
Well, that was kind of my first talk. If you want to go online, you can find a recording of the first talk in the series Beyond the Cosmos, where I talked about how we do know that the causal agent for the universe must be a being with a power to operate beyond 10 space-time dimensions. And where I've seen in the scientific literature some serious discussion of reality beyond the 10 space-time dimensions of the universe is the UFO phenomena. Because we're basically seeing in the UFO phenomena instances where you got phenomena taking place that are physically real in terms that there's physical consequences, but we don't see any physical evidence of the causal agent. And so that basically tells us we're dealing with non-physical reality. And it was Jacques Vallée, who's probably the most prolific of all the physicists writing on the UFO phenomena, says we're clearly dealing with an interdimensional phenomena. In other words, he's saying we're having contact with beings that are communicating to us from beyond the space-time dimensions of the universe. And it's based on the fact that we have a couple of thousand instances where you can see a UFO crashing into the Earth, where the crash site you see that the Earth has been depressed by a foot or more, snow is melted, vegetation is damaged, but there's no debris at the site. no artifacts, no debris. And when the observers see the UFO coming down to the crash site, they hear no sonic boom, and they see no heat friction. Physical objects would give you heat friction and a sonic boom. Physical objects would leave debris at the crash site. But the fact that we see the ground depressed, snow melted, tells us something real was responsible for this, but it's not physical. Which explains why when Carl Sagan addressed this in the class I took at the University of Toronto, he said, there's no such thing as UFOs. That's because his worldview would not tolerate the existence of non-physical reality. As a Christian, my worldview does. And so I'm okay with the idea that God created intelligent life that's not physical, real but not physical. The Bible refers to them as angels and demons. Okay, who's next?
So last question?
Okay.
Maybe this falls into what you just mentioned, but in the creation, when you're mentioning bacteria and you're mentioning human life and plant life, where do angels fall into that?
Okay. The Bible tells us that God created two distinct species of intelligent life. We human beings, who are physical intelligent beings that are constrained by the space-time dimensions of the universe and the laws of physics that govern the universe. He also created angels who can come into our realm, but they're not subject to the physics of our realm. They can come and go. They have their separate realm, a realm beyond ours, with different physics and a different dimensionality. We cannot leave our realm to go into their realm, at least not while we're still alive, but they can come into our realm. But they can exit anytime they want. And you see this in Hebrews 13:2, where it says, many of us have entertained angels unaware, where they kind of come in, they stay for a few minutes or seconds, and then they exit. Or what you see in the UFO phenomena, where they stay around a little bit longer, but that's referring to the fallen angels who intend us physical harm. So in that sense, the Bible speaks about two different populations of angels. The righteous angels that are subject to God's authority, and the unrighteous angels, or the demons, that are in rebellion to God's authority. And the unrighteous ones are doing everything they can to dissuade us from being submissive towards the Creator. Okay, thank you for joining us here. We're going to shut down now because we've got another talk that's going to start in a few minutes. Next week, I'll be addressing the topic, the origin of human beings. And yeah, once again, we're going to live stream it. So, and incidentally, everything's being recorded and posted at paradoxes.org and on YouTube. Thank you.